Here I've listed the positive and negative rational roots that we found in our previous section. Now we're going to try to eliminate some of these possibilities by checking for upper and lower bounds. We'll first check if 1.5, or 3/2, is an upper bound for this polynomial. To find if that's the case, we will use synthetic division with 1.5 as our divisor. If all of our solutions from each step of the synthetic division are the same sign, or 0, this means that that would be an upper bound. However, if even one of the signs is different, that means it is not an upper bound. We'll begin by writing 1.5 in a little box on the left, and we'll write our coefficients from left to right, starting with the highest power. Also note that negative x squared does not have a number, so we'll use the invisible 1 in that position. We'll begin by bringing down the 2, and then multiplying that 2 by 1.5. 2 times that 1.5 will give us 3. Negative 13 plus 3 will give us negative 10. Then we'll take that negative 10 also times the 1.5, giving us negative 15. Negative 1 minus 15 will give us negative 16, and we'll multiply that once again by that 1.5. If we do that, we'll get negative 24. So we'll have positive 9 minus 24, and that will give us negative 15. If we take that 15 and multiply that times the 1.5, we'll get negative 22.5. And then if we add the 3 above, we'll get negative 19.5. Notice that our answer in our last position is not 0. That tells us that 1.5 is not a root. This means we can remove 3/2 from consideration. However, in our solutions to the synthetic division, we have 2, negative 10, negative 16, and negative 15, which means we have a sign change between the 2 and the negative 10. Since we have even one sign change here, that tells us that 1.5 is not an upper bound. Because 1.5 is not an upper bound, we cannot rule the 3 out. That means 3 still could be possible. Now let's check if negative 1 is a lower bound for the polynomial. We'll put negative 1 on the left and again write our coefficients in order. We'll begin by bringing down the 2 again and multiply that times negative 1. We'll get negative 2 when we multiply, and now we take negative 13 minus 2 for negative 15. Take that negative 15 times that negative 1. This will give us positive 15. 15 minus 1 will give us 14, and we'll take that 14 again times negative 1. This will give us negative 14, and 9 minus 14 gives negative 5. Negative 5 times negative 1 gives positive 5, and then 3 plus 5 gives 8. Again, this final answer of 8 is not equal to 0, and this tells us negative 1 is not a root. This also means we can remove negative 1 from consideration. To see if negative 1 is a lower bound, we now look to the signs of all of our solutions from each step of this synthetic division. If every solution has a sign change, this means that negative 1 will be a lower bound. When we examine our solutions, we see that 2 and negative 15 has a sign change. Negative 15 and positive 14, also a sign change. 14 and negative 5 is a sign change, and negative 5 with 8 is a sign change. Since all of our signs change, this is a lower bound. This means anything lower than negative 1 we can remove from consideration. This rules out negative 3/2 and negative 3. However, this still leaves negative 1/2, and that still could be a solution. However, by using this synthetic division, we have ruled out 4 out of 8 of our possible rational solutions. In the next part of the video, we'll see which of those 4 is a solution.